Okay, so this is 7.5's exit ticket, and it says determine if this is a true identity, sine 2x equals 2 sine x. And so my initial gut says no, because the identity is that I'm thinking about is sine 2x equals 2 sine cosine. And so I see this part, and it's oops, and sine. And then they just neglected this cosine here. So my gut is saying no. But what you want to do is prove it and show that, yeah, this 2 inside, someone asked, does the 2 do different things to each side? This 2 is inside. So if I was going to like step by step this, so if you had a number and you knew what x was, then you'd multiply by 2 first, and then you take the sign of that. Versus here, you take the sign and then multiply by 2. So this is kind of like order matters here, right? So this is like, should I put my socks on then shoes, or shoes and socks? Like order does matter. This is not like two, they call them mutually exclusive ideas, where one thing is like, making your bed and brushing your teeth. Those are mutually exclusive, meaning one has no play on the other, right? So the very first thing that I'm going to do, and my tactics for proving an identity are very similar to to solving an equation. So I will use factoring. I won't use sad mapping really, because sad map is true for solving. I will use other identities. I will use get everybody in terms of sine and cosine, but that's kind of it. So one thing that I don't think I've emphasized enough in my classes are you can't divide by a variable. Okay, you can't divide by a variable. So I can kind of show you the reason why you can't. So like let's say we had x squared equals to 2x. And someone's like, oh, Miss Johnson, can't you just divide by x? And then that cancels. So this is 2. And then x squared divided by x is just x. So x equals to 2. I am not saying that 2 is not the answer. What I am saying is that you just lost an answer. So original equation, pink equation says, hey, I have at most 2 solutions, right? You found one, but you don't even know where to find the other one. And some of you are like, but Miss Johnson, like, isn't it plus or minus? No, because you didn't take the square root of it. So no reason to add plus or minus in there, right? So by dividing out here, you actually lost a solution. So instead of doing that, let me show you what you should be doing. So instead, this is wrong. So think this is wrong, right? So instead, one of your tactics is to solve it for 0. So subtract 2x on both sides. So x squared minus 2x equals to 0, right? And then now you would factor and you get x parentheses x minus 2, right? Greatest common factor would be x. And then you'd use the 0 product property. You go x equals to 0 and then x minus 2 equals to 0. So x equals to 0 or 2. You see, like, compare these two. Do you see how on the right we have 2 solutions, on the left we only have 1? And you're like, oh. So this is the reason why you can't divide by a variable, because essentially you're losing a solution, okay? And possibly causing your equation, because if your answer is 0, which in this case it is, you're doing something mathematically illegal. You cannot divide by 0. But you're like, but Miss Johnson, I didn't know I was dividing by 0. It doesn't matter. Do you see how the results of you doing it still shows that you did something wrong because you lost a solution? right, so back to this over here. So the very first thing I'm going to do is I'm going to use the this identity, and then I'm going to see what I can do. So I get 2 sine x cosine x equals to 2 sine x. So here's where I'm trying to say, like, hey, don't do that thing. Don't do that thing where you're going to divide out by 0, right? So don't divide it by sine x, right? So that's one thing. Okay. And then so then you're like, okay, but Miss Johnson, what do I do? So the next thing I'll do is exactly what I did over here, which is set it equal to 0 on the factor. So this is like me more solving it rather than proving an identity, and I'll explain what's going to happen in a second. So I subtract 2 sine x, subtract 2 sine x, and I get 2 sine x cosine x minus 2 sine x equals to 0. So then again, I'm going to factor out the greatest common factor. So I'll leave you some directions here. So factor out okay. So then now what I'm going to do is I'm going to factor that guy out. So that's 2 sine x. And then leftovers is cosine x minus 1 equals to 0. So if you're noticing now, we've moved into the solving land. And if we were proving this identity, we would get something that showed that it was always true. Okay. And so far I feel like my gut feeling was right that this is not an identity. Okay. So then I get 2 sine x equals to 0, cosine x equals to 1. I'm asking myself, okay, so on the left side, I'm sad mapping, so I'm dividing by 2. So sine x equals to 0. When is sine x equals to 0? Here and here. So x equals to 0 and pi, right? And when is cosine 1? Well, when is cosine 1? Oh, that's 0. So x is equal to 0. So here's my answers. When you get solutions like this, that means that this identity is only true when x is equal to 0 and x is equal to pi. Okay. So that's one way to prove this. Another way to prove this is if I go in and I didn't want to do that, but I'm just going to leave it because that's the way it is right now. So the other way that I'm going to prove this is by graphing both sides of the equation on separate graphs. So there's sine 2x, and here's 2 sine x, right? And if it was a true identity, then those two would be exactly the same, right? So let me just really quickly, we do know the identity is true when it's cosine x, 2 sine x cosine x. Do you see how they're exactly the same? See how this graph right here is exactly the same? There's two of them. There's the red and the blue one is right on top of it. But when I erase and this part right here and just show you sine 2x equals 2 sine x, no, it is only true at the points that you see them overlapping, at 0, at pi, at 2 pi, at 3 pi, at 4 pi, and so on. So here's my graph proof that this is not true. Here's my algebraic proof that it is not true. So this is only an identity when x is equal to 0 or pi. So this is not a true identity. So here's my answer. Not a true identity because it is only true when x equals 0, pi, 2 pi, comma, dot, dot, dot. Does that make sense? It's only true when we get those. Does that make sense? Okay. Questions for me. So let me just go over this again. When you're proving an identity, you really want to make one side look like the other or the other side look like the other. In this case, once I got to 2 sine x cosine x equals to 2 sine x, I noticed that I can't get 2 sine x to look like 2 sine x cosine x. So then I started solving it like an equation, and then I found that the only time that it was true was when it was 0 or pi. The next thing I did was I tried graphing it, and that's what I got. Okay, and it's 2 separate graphs because those two aren't the same. Their identities are not the same. Okay, thanks for listening.